And I then convinced myself that, in fact, the probability that the Collatz conjecture itself is unsettleable is very large. I don't expect any of you to agree with me on that, because I can't prove it. I can't prove anything. This paper contains no proofs. But at last, I'm able to rest at night. I'm no longer obsessed by the Collatz conjecture. I've come to a decision about it. The Collatz conjecture is almost certainly true. With what sort of probability is it true? Well, I don't know. But I do know that the probability that it's not provable is larger than the probability that it's true. That's my opinion. Let me try and explain how I came to have that opinion. If you take a number of the form, let me try and think what it is. It's divisible by a large power of 2. And then you take a multiple of some large power of 2, and then you subtract 1 from it. Well, 2 squared times n minus 1, or perhaps I should say 2n minus 1, goes, what does it go to? It's odd. So it goes, we multiply by 3 and get 6n minus 3, and then we subtract 1. That gives us 6n minus 4, I think. Then, well, anyway, you'll find out that if you take 2 squared n minus 1, it goes to 3 squared n minus 1. And if you take 2 to the even n minus 1, it goes to 3 to the even n minus 1. So this is a number that, if you apply the Collatz function, just climbs steadily upwards for a long time. And if you have a number of this shape, which is round about a googol in size, it goes up to what I call 1.5 googols, which, a googol is 10 to the 100. The number I call 1.5 googols is 10 to the 150. That's what I mean by it. It's not 1.5 times a googol. It's a googol to the power 1.5, which has got a lot bigger. And now, in the nature of things, that number will drift downwards under the Collatz function. Okay? And then there's a unique time at which it's between n and 2n, where n is the number we started with. Okay. And when it's in the range, it's greater than or equal to n and less than 2n. That's a collection of n numbers, big N numbers. This n is really quite a big number. And so there's a probability of 1 over big N that it is actually the number big N that we started with. Well, is that really true? It's a probability. That supposes that this number is uniformly distributed in the range n inclusive to 2n exclusive. Well, you can test that. It appears to be uniformly distributed for rather smaller numbers. It appears to be uniformly distributed. And there's no reason to suspect that it's not uniformly distributed. The behavior of modulo powers of 2 and modulo powers of 3 are independent. And so I believe it is uniformly distributed. And therefore, the probability that it gets back to being big N, in which case the Collatz conjecture will be false, because we get to a cycle, is 1 over big N. Okay, that's 1 over a googol. As I remarked, events with probability 1 over a googol don't happen. Okay. But now, is there a proof that that event doesn't happen? If there's a proof that the Collatz conjecture is true, then the scenario I've just sketched out is going to be false. It's going to have a probability of 0. That's why you can't prove it. Because it's actually the probability is 1 over Google. It's not an argument that should convince you if you're the sort of person who demands a proof of everything. But I've already suggested there isn't going to be a proof. And so this is the best argument around. And it convinces me, it has totally convinced me, that the Collet conjecture is not provable. Okay? There's no proof on that set there. Am I finished?